Today's lecture, Theme 10, Tolerance System, Methods and Means of Control of Gears. Please write down to your notes the theme of our lecture and the plan. So, one more time, Tolerance System, Methods and Means of Control of Gears. (10.1) Indicators of kinematic accuracy of gears. (10.2) Indicators of smooth operation. (10.3) Indicators of tooth contact in the transmission. (10.4) Types of wheel-tooth connections in transmission. (10.5) Designation of accuracy of gear wells on drawings. Please write down to your notes our plan. Gears are widely used both in machines and in devices. A particular difficulty in normalizing the accuracy requirements for gears is that the details of these gears are complex in their geometric shape. According to the operational purpose, gears can be divided into four main groups. Please write down to your notes these four main groups of gears. First group, reference. Second group, high speed. Third group, power. And general purpose. It's four main groups of gears. A general requirement for all gears, and especially for those, and especially for those operating at high temperature and in reverse conditions, is the amount of lateral clearance between the non-working surfaces of the teeth. In the developed standards, all requirements for gears are divided into four groups and called accuracy standards. Write down to your notes these sentences. In the developed standards, all requirements for gears are divided into four groups and called accuracy standards. Accuracy standards. So you can see in the slides four groups of standards. The norms, the first group, it's the norms of kinematic accuracy. The norms of kinematic accuracy. The norms of kinematic accuracy establish requirements. Yes? kinematic requirements for such parameters of wheels and gears that cause transmission inaccuracies with a full revolution of the wheel. That is, they characterize errors in the angle of rotation of the wheel for one revolution compared to if there was an absolutely accurate wheel instead.
So we can say it depends on the angle of rotation, yeah?
Yes. One revolution, it's 360 degrees, one revolution.
Yes.
And it's
The angular acceleration and the angular velocity, yeah. So it's they can change it.
It's not about speed and it's not about acceleration.
No, I speak about the wheel, teacher. When the wheel is moving, I think it depends. Yeah.
Speed and acceleration. It's smoothness standards. It's about smoothness standards.
Okay.
Kinematic accuracy. It's errors in the angle. Errors in the angle of rotation of the wheel of one revolution compared.
Okay.
To compare it to if there was an absolutely accurate wheel instead. Our wheels, our gears have errors. First gear and second gear have the errors. And when they rotating, then we will have errors in the angle of rotation compared to if there was an absolutely accurate wheel instead. If we use absolutely accurate wheels, we haven't the errors in angle, but we use the wheels that have errors. So we have errors in the angle of rotation. So the second group of errors of standards, it's smoothness standards. Smoothness standards refer to such parameters of gears that also affect kinematic accuracy, but they appear many times per wheel revolution. Kinematic accuracy, it's only one revolution. And if we talk about smoothness standards, then many times per wheel revolution, it's but the upper many times per wheel revolution. Such requirements are most important for transmission operating at high speeds. Since such errors become a source of shock, leading to noise and vibration. Okay, smooth standards, it's about vibration in gears connection. The third group of standards, it's contact standards. Contact standards establish requirements for the parameters of wheels and gears, which determine the size of the contact surface of the teeth of the matting wheels. Contact requirements are especially important for gears that transmit heavy loads. And the fourth group of standards is the lateral clearance standards. The lateral clearance standards establish requirements for the parameters of wheels and gears that affect the amount of clearance along non-working tooth profiles when their working sides come into contact. If we talk about lateral clearance standards, we talked about non-working tooth profiles. Non-working tooth profiles. when their working sides come into contact. Please write down to your notes, it's 4 groups of standards about accuracy of the gears. The accuracy of gears is determined by many geometric parameters. The tolerance system sets different requirements for the accuracy of individual parameters of wheels and gears, depending on the operational purpose of the gear. 12 degrees of accuracy from 1 to 12 of gears and gears have been established. Please write down to your notes that the 12 degrees of accuracy from 1 to 12 have been established. The accuracy decreases as the number increases. So the accuracy of the gears decreases as the number increases. For each degree of accuracy, standards have been established: kinematic accuracy, smooth operational and contact of GRTs in the transmission. First group, it's kinematic accuracy. Second group, smooth operational. And third group, contact of GRTs. Please write down to your notes this part. Depending on the operational purpose of the transmission, the parameters that determine the 3 types of norms can be combined with different degrees of accuracy. For example, 876. In first place, it's kinematic accuracy. 8 degree of accuracy of 8 degree of kinematic accuracy. 7, it's degree of smooth operation, and 6 is degree of contact of gear teeth, So it can be combined with different degrees of accuracy. Not only 888, it can be 876 or 878, and another type of degrees can be used and can be combined. So we start indicators of kinematic accuracy of gears. Before we start this item of our lecture, let's look a video about parameters of gears. Gear terminology.
Gear change the direction is used with other gear to transmit packaging.
Gear terminology
that meshes with other gear to transmit power from one shaft to another. Gears are used to transfer motion and torque between machine elements. Depending on the construction, gears can change the direction of movement or increase the output speed or torque. In this video, we will understand the terms used to represent different parameters of gear. Pitch circle. A pitch circle is an imaginary circle, which by pure rolling action will give the same rotation as an actual gear. The motion of the two meshing gears is described by their pitch circle's motion. The diameter of this pitch circle is called the pitch circle diameter. This surface of the disc is called the pitch surface. Pitch point. When the two gears are in contact, the common point of both pitch circles of meshing gears is called the pitch point. The surface of the tooth above the pitch circle is called the face of the tooth. The surface of the tooth below the pitch circle is called the flank of the tooth. Circular pitch. The distance between a point on a tooth to the same point on an adjacent tooth, measured along the circumference of the pitch circle, is known as the circular pitch. Circular pitch is denoted by P suffix C, and given by PC equals pi multiplied by pitch circle diameter divided by the number of teeth. Diametral pitch. It is denoted by P suffix D and given by PD equal to number of teeth divided by pitch circle diameter. Distance from the one edge of the tooth to the other is called the width of the tooth. The topmost surface of the tooth is called the top land of the tooth. Tooth thickness. Tooth thickness is the width of the tooth measured along the pitch circle. Tooth space. Tooth space is the width of space between the two adjacent teeth measured along the pitch circle. Addendum. Distance between the pitch circle to the top of the tooth in the radial direction is called an addendum. Dedendum. The radial distance between the pitch circle and the bottom of the tooth is known as the dedendum of the gear. Addendum circle. The circle is drawn through the top of the teeth, concentric with the pitch circle, is called the addendum circle. Dedendum circle. The circle drawn through the bottom of the teeth is called the dedendum circle. It is also called the root circle. Total depth. The distance from the top land of the tooth to the bottom of the tooth is known as the total depth of the tooth. Or total depth can also be given as the sum of the addendum and dedendum of a gear. It is a distance between the addendum circle to the dedendum circle measured along the radial direction. Clearance. When two gears are in meshing condition, the radial distance from the top of a tooth of one gear to the bottom of the tooth of another gear is known as clearance. In simple terms, it is the gap that remained between the top land of one gear and the bottom of another gear when both are in meshing condition. Working depth. It is the radial distance from the addendum of one gear to the addendum of another gear when both the gears are in meshing condition. Backlash. It is the difference between the tooth thickness and the tooth space. Which is this gap? It prevents jamming of the gears in meshing conditions. I hope you have understood the gear terminology. It takes lots of effort to make such informative videos. You can help ADTW learn to make more videos by joining my channel and contributing to developing more such videos.
And one more video. Gear terminology.
Teeth denotes the number of gear teeth. Face of tooth is the surface of the gear tooth above the pitch surface. Flank of tooth is the surface of the gear tooth below the pitch surface. Profile is the curve formed by the face and flank of the tooth. Fillet radius is the radius that connects the root circle to the profile of the tooth. Face width is the width of the gear tooth measured parallel to its axis. Top land is the surface of the top of the tooth. Bottom land is the surface at the bottom of a gear tooth space adjoining the fillet. The outside circle coincides with the tops of the teeth. Outside diameter is the overall diameter of the gear. The root circle coincides with the bottoms of the tooth spaces. Root diameter is the diameter at the bottom of the tooth. Pitch circle is an imaginary circle, which will contact the pitch circle of another gear when in mesh. Pitch diameter is the diameter of the pitch circle from which the gear is designed. Center distance is the shortest distance between non-intersecting axes. Base circle is a circle from which involute form is generated. The pitch point is the point where gear teeth actually make contact with each other as they rotate. The line of action is the straight line passing through the pitch point and tangent to both base circles. Pressure angle is the angle at a pitch point between the line of pressure, which is normal to the tooth surface, and the plane tangent to the pitch surface. Circular pitch is the distance from one face of a tooth to the corresponding face of an adjacent tooth on the same gear, measured along the pitch circle. Tooth thickness is the width of the tooth measured along the pitch circle. Tooth space is the width of space between the two adjacent teeth measured along the pitch circle. Addendum is the radial distance from the pitch circle to the top of the gear tooth. Dedendum is the radial distance from the pitch circle to the bottom of the tooth. Total depth is the radial distance from the top of the gear tooth to the bottom of the tooth. Clearance is the radial distance from the top of the tooth to the bottom of the tooth, in a meshing gear. A circle passing through the top of the meshing gear is known as clearance circle. Working depth is the radial distance from the addendum circle to the clearance circle. It is equal to the sum of the addendum of the two meshing gears. Backlash is the difference between the tooth space and the tooth thickness, as measured along the pitch circle. Theoretically, the backlash should be zero, but in actual practice some backlash must be allowed to prevent jamming of the teeth, due to tooth errors and thermal expansion.
So, indicators of kinematic accuracy of gears. First, the largest kinematic error of the wheel. Second, the largest kinematic error at K steps. Running error. Accumulated error K steps. Accumulated step error. Radial ring, gear runout. Fluctuation in the length of the common normal. Fluctuation of the measured center distance per one well rotation. The largest kinematic error of the gear is the largest error in the angle of rotation of the gear within one turn with a single profile engagement with a precise gear. Please write down to your notes these 8 parameters, indicators of kinematic accuracy of gears. First parameter, Fi suffix IR. The largest kinematic error of the gear is the largest error in the angle of rotation of the gear within one turn 360 degrees, one evolution of the gear, with a single profile engagement with a precise gear. So this distance is the largest error when the gear make one turn. Delta F suffix IR. It's the largest kinematic error of the gear. The standard provides for several equal options for gear accuracy indicators The industry standard of the automobile industry provides in particular for monitoring kinematic accuracy a set of indicators. This set is consist from radial runout of the gear rim and fluctuations in the length of the common normal. The radial runout of the ring gear, F suffix RR, is the difference between the actual limit positions of the initial contour within the gear well from its working axis. The length of the common normal of the gear, W, is the distance between two parallel planes that are in contact with two opposite side surfaces of the gear teeth. Common normal length fluctuation, F suffix VWR, is the difference between the largest and smallest actual common normal lengths in the same gear. Please write down to your notes that for automobile industries used a set of indicators. It's radial runout of the gear rim, FRR, and fluctuations of the length of the common normal, FVWR. Okay. In this figure, you can see a scheme for measuring the radial runout, F suffix RR is this parameter, FRR, of the ring gear and fluctuations in the length of the common normal, F suffix VWR. FVWR is difference between W maximum and W minimum. W maximum minus W minimum. It's parameter FVWR, and FRR is equal R maximum minus R minimum. We use the indicator to determine these parameters, R minimum and R maximum. It's controlled gear and element of original contour. It's element of original contour. So this is the scheme how to determine these parameters. And now we start item 10.2, indicators of smooth operation. Indicators of smooth operation. It's 8 numbers. So first, cyclic error of transmission and gear well. Gear frequency, cyclic error in gear and gear well. Difference between the gear and gear well, it's letter O. If we haven't letter O, so it's about gear well. If you see ZKO R with O, so it's about gear connection. So, gear frequency, cyclic error in gear, local kinematic transmission error and gear well, and phase pitch deviation, deviation of the main step of engagement. 6. Tools profile error. 7. The difference between the steps. And 8. Fluctuation of the measuring axial distance on one tooth. Write down to your notes these 8 parameters. It's indicators of smooth operation. The standards provides for several equal variants of sets of indicators of accuracy of gears. The industry standard of the automobile industry provides in particular to control the smoothness of a set of indicators. The deviation of the main step of engagement, F suffix PBR, FPBR, deviation of the main step of engagement, and the error profile of the tooth, F suffix FR, tooth profile error, F suffix FR. So the 5th and 6th indicators are used to control smoothness in automotive industry. Please write down to your notes these 8 parameters and a set of indicators for automobile industry. Do it now. We have the guest on our lecture. Good day, Олена Харківська. Все гаразд. У нас є, як зазвичай, Камал. Він кожного разу приходить на заняття.
Молодець. Скажите ему, что он
Так,
молодец.
він буде у нас відмінником.
Это учебный отдел отметил. А то я на английском не скажу. Так.
Все у нас гаразд. Є лекції, є запис лекції.
Добре.
Вкладаємо на сайт, на курс ресурс. Ну і презентації є, все на англійській мові.
Хорошо.
Стараємося.
Хорошо. Дуже добре. Удачі вам.
Дякую.
До свидання.
Goodbye. See you later.
Goodbye.
Please, Kamal, write down to your notes these parameters. Deviation of the engagement step is the difference between the actual and nominal engagement steps. F suffix PBR is equal PBR minus PB. You can see in this scheme, this distance is PBR and this dimension is PB. We have the nominal profile and actual tooth profile. Difference between nominal and actual tooth profile, it's FPBR. It's deviation of the engagement step. It's schemes for monitoring the deviation of the main step of engagement. You can see in this figure. The real engagement pitch is understood as the shortest distance between two parallel planes touching two active side surfaces of the same name of adjacent gear teeth. The real engagement pitch is understood as the shortest distance between two parallel planes touching two active size surfaces of the same name of adjacent gear teeth. And the next parameter, it's tooth profile error, F suffix FR. Nominal distance between two closed to each other nominal and face profiles of the tooth between which the actual profile is located. In this scheme, for monitoring the deviation of the errors profile of the tooth, F suffix FR. You can see active tooth surface, its surface, actual tool profile, excuse me, actual tool profile, its actual, and nominal involutes. It's nominal involutes and actual tooth profile. And distance between these two nominal involutes, it's F suffix FR. It's tooth profile error. Have you questions about indicators of smooth operation and indicators of kinematic accuracy of gears? Okay, you have the questions. So we start the third item of our lecture. 10.3 indicators of tooth contact in the transmission. If the contact of the teeth is not along the entire length of the tooth, the specific load is distributed, unevenly worsening lubrication conditions, which leads to reduced durability of teeth and intensive wear. Normalize the smallest size of the total contact spot. The total contact spot is the part of the active lateral surface of the tooth of the well on which are the traces of feet of the tooth of the pair of gears in the assembled gear after rotation under a given working load. In figure 7.5, you can see a scheme for controlling the total contact spot. The contact spot is determined by the relative size in percent. Along the length of the tooth, the ratio of the distance A between the extreme points of the traces of feet except for clearances C, except this clearance. That exceeding the value of the modulus in millimeters to the length of the tooth, B. Length of the tooth, B. So it's A minus C divided by B and multiply by 100%. And we have the relative size in percent along the teeth, along the length of tooth, along the height of the tooth, along the height of the tooth. The ratio of the average along the entire length of the tooth height of the feet traces h suffix m, hm, to the height of the tooth of the corresponding active lateral surface, HP, HP, HP and HM. So HM divided by HP and multiply by 100%, and we have a relative size in person along the height of the tooth. Grinding and running teeth of the connected wells improve their contact. To compensate 10.4 types of wheel tooth connection in transmission. Types of wheel tooth connections in transmission. So to compensate for errors in the manufacture and assembly of the gear, to create design lubrication conditions, as well as to exclude the possibility of jamming of the tooth when the gear is heated, it is necessary to have a side clearance or gap between the non-working profiles of the teeth of the mating wells. The lateral clearance is measured in the transmission in a section perpendicular to the direction of the tooth in the plane tangent to the main cylinders. The gear tolerance system sets a guaranteed or minimum side clearance, J suffix and minimum. Not in all cases the exact gear should have small clearances. The standard provides for 6 types of connections that set different values of J and minimum. It's A, B, C, D, E, and H. And the tolerance on it, T suffix JN, and small letters of the designation of tolerance A, B, C, D, H. You can see these parameters in figure 7.6. Scheme of the tolerance fields for the types of coupling of teeth of gears. You can see guaranteed lateral clearance, J and minimum, and tolerances A, B, C, D, H, A, and one more H. It's tolerances of the lateral clearance. The standard also provides for increased tolerances X, Y, Z. These tolerances are used in special transmissions. Now, please write down to your notes figure 7.6, this scheme, and use zero line and tolerances of the lateral clearance. Do it now. And if you finished, we can scroll the slide. Next, on the next slide, you can see the table 7.1. It's correlation of types of connection, types of tolerances, and classes of deviations of the axial distance. You can see the joining A, B, C, D, E, H. It's joining with different values of J and minimum. This distance is A, this distance is B, C, big D, and E, H. The distance J, if you have big H, then J and minimum is equal 0. So you can see these parameters in first row A, B, C, D, E, H, and the degree of accuracy according to the norms of fluency. For the A, it's from 3 to 12. For the B, it's from 3 to 11. For the C, it's from 3 to 9. For the D, it's from 3 to 8. And for the E and H, from 3 to 7. Minimum lateral clearance, J minimum, 0 for the H, and for the E by IT grade 7, IT grade 8 is for the D, by IT grade 9 is for the C, for the B and for the A, IT grade 10 and IT 11. Type of tolerance you can see in this scheme. Type of tolerance, small letter, small a, small b, small c, small d, it's tolerance fields, and A is the largest tolerance field, H is the smallest tolerance field. So for A, it's small a, for joining B, it's small b, for C, small c, D, for E, it's small h, and for H, it's small h2. And classes of deviation of axial distance. For A, it's 4 class. For B, it's 5 class. It's 6 class. 6 class, 5 class, 4 class, 3 class, class 2, and class 2 for E and H. Guaranteed lateral clearance is formed by reducing the thickness of the teeth, receiving an additional shift of the output circuit, minus E suffix HS for gears with external teeth, and plus EHE for gears with internal teeth. From is nominal position. Tolerance T suffix H, you can see where you can see in this type of tolerance. So tolerance T suffix H for displacement of the original counter. Gear cutting tool is set depending on the tolerance for radial runout F suffix R, type of interface, and T suffix H is more than FR, F suffix R. Please write down to your notes the table 7.1. This table, it's need to be in your notes. In figure 7.7, you can see displacement of the initial contour. Initial contour. 1 is nominal position. 1 is nominal position. And 2 maximum additional displacements. First and second maximum positional displacements. It's tolerance field and distance between A and C. So designation of accuracy of gear wells on drawings. Let's see on examples. First example, 7C. Transmission with a degree of accuracy of 7 for all 3 norms, with the type of connection of the wheels C and type of tolerance small c on the lateral clearance. Second example, 876BA. Transmission with degree 8 according to the norms of kinematic accuracy. In the first position, kinematic accuracy degree. Degree 7 according to the norms of smooth operation. Degree 6 according to the norms of tooth contact, with the type of connection big B, the type of tolerance small a, on the lateral clearance and the correspondence between type of connection and class of deviation of axial distance. And the third example, 7CA 5 128. Transmission with a degree of accuracy of 7 according to all 3 standards, with the type of connection big C, the type of tolerance small a on the lateral clearance, and the coarser class of deviation of axial distance B, and reduced guaranteed lateral clearance is equal 128 micrometers. So it was the last slide of our lecture. Have you questions about this lecture, about gears and all indicators that characterizes the gears? You haven't the questions, so our lecture is finished. See you on Friday. It will be practical lesson. Goodbye.